Algorithmic thinking. Every day, Maya follows steps to solve problems, getting ready for school, playing games, or following instructions. But did you know that computers also solve problems using steps? This step-by-step way of thinking is called algorithmic thinking. Whenever we complete a task by following steps in the correct order, we are using algorithmic thinking. It helps us break big problems into smaller, manageable steps so they can be solved easily and correctly. An algorithm is a set of clear, step-by-step instructions used to solve a problem or complete a task. Algorithms are not just for computers. Humans use them every day. Each step is performed in order. If we miss a step or change the order, the task may not be completed properly. That's exactly how computers think too. Algorithmic thinking means understanding the problem, breaking it into smaller steps, arranging steps in the correct order, solving the problem logically. This type of thinking helps us solve problems efficiently and accurately. Algorithmic thinking is part of computational thinking. Computational thinking means thinking like a computer to solve problems. It includes breaking problems into parts, finding patterns, creating step-by-step solutions, and testing and improving them. At this level, algorithms are written in simple language using steps, not programming code. Good algorithms are clear, ordered, and have a clear start and end. Each instruction tells the computer, or a person, exactly what to do next. Sometimes, it's easier to understand an algorithm when we see it visually. A flowchart is a diagram that shows the steps of an algorithm using shapes and arrows. Each symbol has a special meaning. Together, they show how a solution flows from start to end. Flowcharts are very useful when decisions are involved. A diamond shape asks a question, and the flow follows different paths based on the answer. A conditional statement checks whether something is true or false and then decides what to do next. Conditions are used when different actions are needed in different situations. A loop is used when an action needs to be repeated. Instead of writing the same step again and again, loops save time and effort. A finite loop repeats steps a fixed number of times and then stops. An infinite loop keeps repeating and does not stop on its own. It continues until a stopping condition is applied. Flowcharts can also show loops. Arrows are used to send the flow back, showing that an action is repeated until a condition is met. Many algorithms use both loops and conditions. Algorithmic thinking helps us solve problems clearly and logically. By writing steps, using conditions, repeating actions with loops, and visualizing solutions with flowcharts, we can create accurate and complete algorithms. These skills help us not only in computer science, but also in everyday life.